So, today we're diving into something pretty radical in the world of AI. What if, instead of just trying to make these models smarter, we could actually force them to reason with real integrity? We're going to break down a protocol that claims to do exactly that by essentially hacking the very core of how they work. And this quote right here, it just nails it. This was said by an AI about this very protocol. Think about that for a second. This isn't just some small tweak. We're talking about making the fuzzy, abstract idea of reasoning into a concrete program that any large language model can actually run. All right, Section 1, the 3-pass protocol. At the heart of all this is a really simple but incredibly powerful framework. So let's get into what it is.
Okay, it's called Debate-Way RTM, which stands for Reasoning Through Modeling. Now, this is not just some clever prompt you type in. It's a formal, structured process. It basically creates a little debate, an adversarial simulation, that forces the AI through this super rigorous pattern of argument, then counterargument. The real secret sauce, though, is how it uses the model's own text prediction engine to lock all that logic in place.
The whole thing unfolds in 3 very distinct stages. First, the AI has to build a solid case for something. Then, and this is key, it's forced to argue against itself. And finally, it has to step back and act like a neutral judge to decide the most likely outcome. Let's look at each pass.
So pass 1 is the affirmative build. The goal here is simple: make the strongest possible case for a certain position. It's structured to think through chronologically, to pull in actual real-world examples, and even to predict what might happen next. This pass really builds the foundation for the entire debate.
And now for the really crucial twist, Pass 2, the devil's advocate. The AI literally has to become its own opponent. It has to build an equally powerful, evidence-based counterargument that directly attacks the points it just made. This creates what the protocol's creator calls epistemic friction, this amazing conflict between 2 opposing views that just forces a much deeper level of thinking.
And finally, in Pass 3, the synthesis, the model switches roles again to become a neutral judge. It lays everything out in what's called a clash matrix, a direct point-by-point comparison of the claims from both sides. It then gives its final neutral prediction. But here's the brilliant part. It also has to list falsifiers, actual real-world events that, if they were to happen, would prove its own prediction wrong. This makes the whole thing completely transparent and testable.
Section 2, exploiting the engine. So that's the 3-step structure. But the real genius here is why it works. See, this protocol doesn't try to teach an AI how to think. It just brilliantly exploits the engine that it already is.
And this is really the key question, right? How does a structured debate stop the model from just making stuff up or wandering off on a tangent? Well, the answer lies in understanding what a large language model truly is.
You know, the biggest mistake most of us make is thinking of an AI as a mind that knows things. It doesn't. The reality is, it's a prediction engine. Its only job, its entire purpose, is to generate the next most likely word based on all the words that came before it. It's an incredibly sophisticated pattern matcher, but it's not a thinker. And that brings us to the core mechanic being exploited here, the token lock-in effect. Every single word or token that an AI generates becomes a fixed, permanent part of the context. So once Pass 1 is written, it's locked in. That forces Pass 2 to address that specific text, token by token. It can't just ignore it or drift away. This is the hack that forces logical consistency.
This quote from the source material just sums it up perfectly. The RTM protocol basically uses the AI's nature as a prediction engine against itself. By staging this friction between different identities, the affirmative case, the devil's advocate, it transforms a simple statistical process into a structured, logical debate.
Section 3, testing across universes. Okay, but does this cool theory actually hold up in practice? To prove the protocol was solid, it was put through a really rigorous stress test.
To make sure this wasn't just some weird quirk of one particular system, the protocol was stress-tested across a bunch of different AIs, including models like Grok and Gemini. The whole point was to prove that the principle itself was universal. A super important principle for the test was something the creator calls chat universe isolation. All this means is that every single test is run in a brand new, totally clean chat session. Why does that matter? Well, it ensures the model isn't being contaminated by some memory from a previous conversation. It forces it to act as a completely clean slate system for every single test.
The process itself was really methodical. First, develop the protocol. Second,
run it on completely fresh models in these new clean chat universes. The goal was to confirm that the models would follow the debate structure without ever having seen it before, and, most critically, to prove there was zero information bleeding over from one test to another.
And the result? It worked. The creator confirmed that the tests showed zero cross-belief contamination. The models behaved exactly like stateless, isolated systems, which proved not only the protocol's integrity, but the soundness of the testing method itself. Section 4. A new path to truth. Okay, so this protocol is way more than just a clever technical trick. It really points to a fundamentally different way of thinking about AI alignment and how we even get to truth inside these systems.
The way things are usually done with AI safety is what you could call training for belief. The big labs try to teach the AI what they believe is the correct or safe version of the truth. The RTM approach, it's completely different. It's about designing a neutral procedure that forces a reliable conclusion to emerge from a structured debate, no matter what the AI was originally trained on.
And this gets to the fundamental problem with training for belief, doesn't it? I mean, whose truth are we teaching it? Whose values are getting encoded? Who gets to decide what's right? This method doesn't get rid of bias. It just hard-codes the trainer's personal bias directly into the machine.
The source material gives this perfect real-world example. Just look at Grok from xAI and DeepSeek from China. Both labs would tell you they are training their models for truth, but one reflects very Western techno-libertarian values, while the other reflects state-aligned collectivist values. They end up producing totally incompatible versions of reality, which just proves that training for truth really means training for a specific worldview.
And this is exactly why a procedural approach like RTM is so powerful. It just sidesteps that whole messy problem of whose truth do we teach. Like the source says, you're not trying to make the model smarter, you're making its process safer and way more reliable.
And that leaves us with a really provocative final thought. Maybe the future of safe, reliable AI isn't about trying to build a perfect synthetic mind with all the right beliefs. Maybe, just maybe, it's about architecting a better process, a neutral, transparent, and adversarial system that forces truth to emerge on its own, instead of being dictated from the top down.